So the points P and Q have position vectors 6i plus j and 3i minus 5j respectively. Find a vector equation for the line passing through P and Q. So this one had 3 marks. So this is easy. To find the vector equation, we normally use this formula. You can just say A plus lambda B, where A is a point on that line and then B is the direction vector. So to find this, all you need is any of the 2 points along that line. So in this case we have P and Q. Let me just write our data. So our OP is 6i plus j, and then our OQ is 3i minus 5j. So to find the direction, we can just find the direction vector PQ. This should give us the direction of this equation. So now this is PO plus OQ. Another one can say this is OQ minus OP, depending on what you were taught. So my students were taught this in mathematics. I didn't want to change what they knew, so I'm stuck with this. But if you normally use this one, you can use it. So your PQ is PO. PO is the opposite of this. So this is OP, this is PO. So you can just put the negative sign and say 6i plus j, and then plus OQ. OQ is 3i minus 5j. So now when you simplify this, you have minus 6i minus j plus 3i minus 5j. Then like terms together, this negative 6i plus 3i, we have minus 3i, and then negative I minus 5j, we have minus 6j. So this is our direction vector. Another one can factor out the 3 and say this is I plus 2j. This will also be the direction vector. Another one can say 3 negative I minus 2j. This will still be the direction of that vector. So for now, I'll just use this. So that means we have R is equal to A is any point on that line. So I can either pick this or this. So I'll go with the first one, 6i plus j, then plus lambda. Our B is the direction vector. So I'll go with this one here, minus 3i minus 6j. And you're done. This is your vector equation. On part B, find the position vector of the line or the points N on PQ such that ON is perpendicular to PQ. So to solve this, we can start by finding PQ. Since this vector is perpendicular to PQ, we know that ON multiplied by PQ will be 0. So now let's find PQ. Of course, we can start with ON. Remember, ON is on the line PQ. So that means there is some lambda which should satisfy this equation to give you your ON. So in other words, your ON, you can find your ON by finding an appropriate lambda for this. like that. So you can even leave it like this, but I'll put it in ij component form. So I'll start with the i's and then I'll put the j's this side, so that we can multiply this by pq and equate it to 0. Remember, when two vectors are perpendicular to each other, their dot product is always a 0. So we have 6i plus j, then this one will be minus 3 lambda I minus 6 lambda j. So your ON will be, you get this one with this, you factor the I out, so you have 6 minus 3 lambda I, and then the j's with the j's, so you can say this is 1 minus 6 lambda j. So this is your ON in terms of lambda. And then let's find our PQ and take advantage of this fact. So PQ is PO plus OQ. All these are vectors, by the way. So our PO is, I think we found PQ. Yes, we did. Our PQ, yes, this is our PQ here. So our PQ is negative 3i minus 6j, this one there. So all you need to do is multiply ON by PQ and then equate this to 0. And then this should give you the value of lambda, which you can substitute here to find the exact direction of, to find the position vector of ON. So let's multiply these two. You can say ON dot PQ is 0. The reason is simple, the two are perpendicular to each other. So OP is, ON is 6 minus 3 lambda I, then plus 1 minus 6 lambda j. This is being multiplied by OP, which is negative 3i minus 6j, then this is equal to 0. So you can multiply the I by the I. So this times this will be negative 3, 6 minus 3 lambda, then plus this multiplied by that. This one will be minus 6. 1 minus 6 lambda is equal to 0. So when you solve for lambda, you can just substitute this in ON to find the exact value of ON. So this multiplied by this will be minus 18. This multiplied by this will be positive 9 lambda. Okay, I got disturbed. So this multiplied by this one will be minus 6. This by this, we have 36. Lambda is 0. And then we can add the like terms. This plus this. So we have 9 lambda plus 36 lambda is this one minus this. This is minus 24. So you can take it to the other side so that it's positive. And then this plus this one will be 45, I think. 45 is 24. Then divide both sides by 45 so that your lambda is, you can reduce your numbers. Which number can go into this? A 3 can go into 24. That's 8 times. Then a 3 can go into 45 15 times. So this is your lambda. So to find your ON, you can use this now. You can use this equation or this, whichever you want to use, with the value of lambda, which is this. So I'll use the second one, the third one, because it's much easier. So ON will be 6 minus 3 multiplied by lambda, which is 8 over 15 I, plus 1 minus 6 multiplied by 8 over 15, and then this is j. Remember, lambda is 8 over 15. So this into that's a 5. 3 into this, we have a 2. 3 there, we have a 5. So we can say we have 6 minus 8 over 5 I being added to 1 minus this multiplied by this is 16 over 5 j. So when you subtract these two, you have 22 over 5. This is 30, 22 over 5 I, and then plus this is actually a negative number. That would be negative 11 over 5 j. So this is the position vector of ON, and you're done.